Namaskar, once again Sithigan sir welcome you to this class on probability. Last class we have discussed about how to calculate a standard deviation variance of a probability distribution table. The probability distribution table, you already know how to calculate, how to do the problems of that. So there I have told last class, when the experiments are independent, then we will put into the another theory is called as binomial distribution and or Bernoulli trials. So today we will learn about the Bernoulli trials and binomial distributions. Dear students, what is called Bernoulli trials? An experiment is independent which has give only two outcomes. An experiment, independent experiment which has only two outcomes, either success or failure. That type of experiments are called as, that type of experiments and events are called as Bernoulli trials. Now I am showing you an example in your front. Suppose a coin is tossed. If this coin is a 10 rupees coin, I am going to toss. If I will toss, either it will give head or tail. When it will give head, it cannot give us tail, and when it gives tail, it cannot give heads. Then its outcomes are only two. There are many questions you have seen in your examination which has two types of answer, either yes or no. Or many experiments are there in the nature, they are in dichotomous nature. Dichotomous nature means only two outlets. If a cricket match is played, then results either one will win or lose. There is no draw, no tie. This concept should not be there. Then that type of experiments are called as independent experiments. One experiment consists of several trials. Suppose these coins I will toss two times. One time I noted what it is occur head. Then second time I have tossed and again I got head. So it is head. I am noting down it. First instant it is head. Second instant it is head. Two times head comes. So then getting a head in the fastest. Getting a head in the fastest is automatically is naturally independent of getting a head in the second toss. The occurrence of first one does not influence the occurrence of second one. That type of trial is called Bernoulli trials. They already have stated here so many examples before you where you can only two types of dichotomous nature. Dichotomous nature means only two outcomes, and which is favor to us we are denoted as the success, which does not favor us we denote as failure. There are two words, success or failure. This type of experiment is called as Bernoulli trials. So students, now will start from here. Then by taking that you are doing probability distribution table, and that table obey the expansion of binomial. That's why it is known as binomial distribution. That's why it's known as binomial distribution. Let us take an example, see what happens in this while we are doing the probability distribution table. So for Bernoulli trials and binomial distributions, that should be noted as binomial distribution, always written B stand for binomial. There are two parameters n and p. What is that n p? We will see that there are two parameters, either n or p. A distribution is called as binomial distribution. These things must be, you will check out there. What? The number of trials should be finite. Number of trials of experiments should be a finite quantity. Means you can do 20 times, you can do 10 times, you can do 5 times. So the number of trial should be a finite number. Number of trials trial should be finite. Should be finite. That means you can perform tossing a coin in finite times. It will not go to infinite. If you will go to infinite, then Poisson distribution will come. I am not going to details about Poisson distribution, only binomial. Number of trials should be finite. Now second point you have to see, the point 2. Point 2 is whatever we are taking as trial, it should be independent trials. So independent, the number of trials should be independent. Trials should be independent to each other. They should be independent. And third, each trial should have two outcomes. Only two outcomes. Two outcomes. That is either success or failure. There are two words, which is favor to us is called as success, which does not favor to us is called as failure. So these three conditions will satisfy, then we can tell that is called Bernoulli trials or binomial distributions. And n is known as number of trials. N stands for number of trials. In a experiment, number of trials. And P stands for probability of success. Probability of success in one trial. So once again I am revising. Any experiment you will do, to perform that experiment you are conducting several trials. Means a coin is tossed 3 times. Means this experiment to be performed means you have to toss a coin 3 times. Then there are 3 independent trials. These are 3 independent trials. Occurrence of one does not affect the occurrence of other. That's why independent trials is called Bernoulli trials. And the trials must be independent to each other. One does not affect to another. And it must have finite number of times trial can be tossed. That means the number of trials should be finite. It should be a finite number. The counting has an end. That counting that trials should be finite. It's a finite number. Second, trials should be independent. One trial is independent to other. That part is clear. So coin 1. The tossing of the coin, first coin does not affect the tossing of second coin. They are independent trials. They should be independent. Each trial should have only 2 outcomes, either success or failure. That is called dichotomous in nature. Dichotomous in nature means any experiment has 2 outlets, either yes or no, or success or failure, defective or non-defective. If ball you are drawing a ball, whether it is defective electric ball or non-defective electric ball, there are 2 outcomes are here. Hatched, egg are hatched or not hatched, and yes or non-yes. So only 2 outlets are there. They are called as Bernoulli distribution or Bernoulli trials or binomial distributions. So now look at it. A probability of success in one trial, because trials are independent to each other. Then I am writing why it is called binomial distribution. I am doing this one. It is obey the things, and if P is told as probability of success in one trial, we are taking late. P already decided that P be the probability of success in one trial. one trial. Then Q be the probability of failure in one trial. Then as two outlets are there, definitely Q plus P is equal to 1. That implies if P is known, I can find Q. If Q is known, I can find P. This is the binomial. That's sum of the probabilities P and Q in one trial is always equal to 1. That part. And second, this n I am talking about n is called the number of trials that is equal to, I am writing a very interesting words here. Number of trials is equal to the maximum value of random variable. The maximum value of random variable is called as n number of trials. And trials are independent. These are called independent trial. Independent with replacement. Independent means with replacement. With anything you do with replacement, that is called Bernoulli independent event. Then this side I am doing its theory. Why we are calling as binomial distributions. Now if I apply binomial over it of Q plus P is equal to 1, always failure first and second is success in one trial. Applying nth power, n is the number of trials, so it is equal to 1. And 1 to the power n is equal to 1. Now expand it. If you will expand binomial expansion, n is a natural number, n here natural number, n is a whole number it can, or n is a natural number or whole number, then we can expand like this: Cn0 q to the power n of p to the power 0 plus Cn1 q to the power n minus 1 p to the power 1. So dot there is a general term NCR q to the power r p to the power n minus r plus last step Cnn and p to the power n is equal to 1. And these are the terms of the binomial expansion. This is known general term. This is known as general term. A general term of the binomial expansion. This is known as general term of the binomial expansions. This is. And if I put in a table, this is called binomial distributions or probability distribution table PD with the help of binomial. Here random variable x, and here its probability, and when x equal to 0, I am putting x equal to 0. So it is a whole number, it's a whole number. You can put 0. So starting from 0, then 1, then 2, then dot r, then dot this is r, and then this is n. I am putting dot up to n. This is the value of random variable. These are the value of random variable. Now all of you look at, so NC0 means this is NC0. Its formula is NC0 q to the power n and p to the power 0 is equal to 1. This is the first term. This is the first term of this. This is the second term. This is your first term. The x equal to 0, we are getting this. And this is the second term at 1, that is 1. So if I will put here, then this will come Cn1 NC1 Q to the power n minus 1 into P. So like that you can fill up. I am fill upping rth place, little big I am making. So rth place, it's rth place. So that is equal to NCR Q to the power R, P to the power n minus R, this is, and nth place CNN P to the power n, and that's sum of the all probability. Already you've seen that it is equal to 1. Sum of the all probability is equal to known as 1. This is called binomial distribution table. And this is why its name is binomial, that I told. It's you are using the expansion of binomial expansion to find this distribution. That's why it's called binomial distribution table. And this is the general term. This is, you know, that general term. Then we got the formula for any random variable. The formula Px equal to R, the general term x equal to R is NCR P Q to the power n minus R and P to the power R. Sorry, here we did mistakes. It is Q to the power n minus R and P to the power R. It is Q to the power n minus R and P to the power R. It is NCR Q to the power n minus R, P to the power R. So what is here? That should be there in the power of the success. So this is probability of success. This is failure. This is failure. This is success. So failure and success, and this is the random variable values. R takes the value 0, 1 up to n. R takes the value 0 to n. R takes the value 1, 0, 1 to n. So when 0, Px 0, this is you will get. P1, this one will get. So similarly you can go it. So this is, and here some point I will discuss whole things. This is about binomial distribution, how to find binomial, why its name is binomial, and their addition of both the probability in the one trial, that is 1. If you know one, then you can get other. So all the things clear, and just so after expanding this, then some points I am writing. This is, so both the side expansion I did, Q, always write student Q plus P to the power 1 is equal to 1, failure first and success is second. This expansion you got, both the side 1 power given, you got this one. So this is the 3 points you have to remember. Number of trials should be finite, trials should be independent, each trial should have only 2 outcomes, only 2 outcomes, that is success or failure. Let P be the probability of success in one trial, Q be the probability of failure in one trial, then addition of these two should be equal to 1, and number of trial n is equal to number of trials, that is the maximum value of random variable, that this n is called number of trial, maximum value of random variable, max value of x, n. So very interesting. Then we'll go to find what is the mean and other things. So now I'm writing the mean of binomial expansions. So somewhere I'm writing the mean. So mean for binomial expansion mu is equal to NP, number of trial in probability of one success, n into P is equal to mean of the binomial expansion. This is very easy for you. Then variance equal to NPQ, NPQ, P is the probability of success in one trial, Q is the probability of failure in one trial, n is the number of trial. Then standard deviation, this is variance, and Q is equal to NPQ root over that is called standard deviations. SD, standard deviations, that is called standard deviations. These 3 points you note down. It is very easy to see all the theories of binomial or Bernoulli experiments. Okay, students, after discussing all the theory and one slide, everything in this green board, just you take a glance over it, then we'll start discussing the problem. Okay, students, now we'll see the first question on binomial distribution. This you can apply binomial or by generally what you did in the previous chapter you can do by that way. Once you know this binomial, then it is easy to write down the probability distribution table. How to know whether it is a binomial or conditional, what will apply here. Now look at it. So find the PD. PD means probability distributions. Find the PD of number of doublets. Number of doublets in 4 throws of pair of dice. Look at it here. Pair of dice, this is, and this is considered as one trial. This pair of dice is known as one trial, only one trial. These trials, how many trials? Now throwing a pair of dice considered as one trial. That type of things, how many times you are doing? 4 times you are doing, 4 times. Then you know that if it is 4 times, then we are going to find the number of doublets. What do you mean by doublets? First you analyze the question. Doublets are called as 1, 1. Both the face shows same number. Both the face will show same number on 2 different dice. So 1, 1, 2, 2. And these are called as up to 6, 6 is called as doublets. To getting a doublet, how many dice are required? How many die are required? How many die are required to getting a doublet? Minimum 2. So to getting that type of output, we require one trial consists of throwing a pair of dice. Then how many times you are throwing? Then what is your X? So solution here, and now you will interact with me one by one. X represent, X is the random variable, X is the random variable, represent the number of doublets. X is the random variable, represent number of doublets. Number of doublets. X is the random variable, represent the number of doublets in 4 throw a pair of dice. Then X will take the value. What are the value? Yes. What are the value? I may not get any doublet. I may get 1 doublet. I may get 2 doublet. I may get 3 doublet. I may get 4 doublet. Because 4 times I am throwing, then it can be takes maximum value of it. Maximum value is equal to 4 times. A pair of dice is responsible to get a doublet. Then one pair considered as one trial. How many that pair, how many times it is thrown? 4 times. Then its maximum value is 4, then 3, then 2, then 1, then 0. So that means 0 represent no doublets, 1 doublets, 3 are non-doublets, 2 are doublets, 2 are non-doublets, 3 are doublets, 1 is non-doublets, all 4 are doublets. Already I told, if 4 the maximum value of random variable, this is called maximum value of random variable, maximum value of random variable, RV, random variable, maximum value of random variable is equal to 4, then number of trials is equal to number of trials is equal to 4. And which type of trial they are? Does one pair output affect the another pair of dice output? No. One is not influence the occurrence of other. So they are which type of trial? Independent trial. That means we got there are number of independent trials means Bernoulli trials. That is about Bernoulli trials. Question number Bernoulli trials. Then I understood independent. So their number is 4, maximum value of random variable equal to number of trials. These trials are independent to each other. Every trial is independent to other. So then I got binomial distribution. Then I am going to find its table. Suppose I am going to doing the table. First x value I am writing 0, 1, 2, 3, 4. These are the value of random variables. These are the value of random variable table. So first is showing about the random variable. In this way I am doing. So it is, then I will find their probability. Their probability is Px. Their probability is Px. So now Px is their probability. Px their probability. So now finding probability I will take the help of binomial distributions. So all of you know that this is the formula I told. X equal to R is equal to NCR, P to the power Q to the power N minus R and P to the power R. This is the binomial formula to find out probability distribution. First I will put Px equal to 0. Now putting x equal to 0 and what I will get NC 0, Q to the power 0 and P to the power NC to the power N and Q to the power 0. Now first of all you got this one, and what is P and what is Q? P is the probability of success. P is the probability of success in one trial. So one trial I already wrote, pair of dice thrown, this doublet will occur. This is the doublet, already I have written doublets. To get doublets in one pair, then we'll get how many? 6 are there. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 5, 6, 6. There are 6 out of 36. Out of 36. Then I got 1 by 6. And Q is already, you know that 1 minus 1 by 6, that is equal to 5 by 6. In one trial, this P and Q, P is called probability of success, about success, and Q is called probability of failure, in one trial. Okay, all of you. So P you got, Q you got, and how to get? P is a number, is equal to 1 by 6. Q is a number, is 1 by 6. Now you can verify both you are is equal to 1. Both you are is equal to 1. That's why 1 is calculated 1 minus other. 1 is calculated 1 minus other. So then we got probability success, failure in one trial, because doublet are 6. There are 6 numbers, doublets are there. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. There are 6 and 2 dice can be thrown. The total number of possible outcomes is 36. So 6 by 36 I got 1 by 6, then I got. Now I can fill up here by these questions. So what are the things I will get here? So Px0, here Q to the power n, that will gives you now 1 by 1. If you put 1 by 6, then Cn0 is equal to 1, Cn0 is equal to 1, and this is 1 by 6 to the power n. 1 by 6 to the power n, and this will gives you 1 by 6 to the power n. N means here n is equal to how much? 4. N is equal to 4. N is equal to 4, already you found. N is equal to 4. That is equal to 1 by 6 to the power 4. Then first one I got 1 by 6 to the power 4. Then second one what will comes? So 1 by 6, because here will come as, now put, then I will go for Px equal to 1. Px equal to 1. So already Cn is equal to 4, 4, 1, 4, 1, and Q is equal to 5 by 6. It is equal to Q to the power n. Sorry, it should be 5 by 6 to the power 4. So that is 5 by 6 to the power 4, 5 by 6 to the power 4, and P is equal to 1 by 6, Q is equal to 5 by 6, P equal to R, n minus R is equal to 0 here, putting R is equal to 0, this is n is equal to 4, that is 4, 5 by 4 is this. Now I am going to 5 by 4, and it is equal to 1 this minus 3 and 1 by 6. 5 by 6 to the power 3 and into 1 by 6. So 4 by 1, it is equal to how much? it is equal to, sir, it is equal to 4, and that is equal to, I write 4 into 5Q. So 4 into 125, this is 125 into 4. So that will calculate, that one I am writing, 4 into 5Q 125 by 6 to the power 4. Second one, 6 to the power 4. Then 2, now I will going to calculate 2, second, 2 I will calculate. Now Px equal to, Px equal to 2, Px equal to 2. So C42, 5 by 6 to the power 2 and 1 by 6 to the power 2. 1 by 6 to the power 2. So then what will get? 4C2 is equal to 6 and 6 and is 25. So it will come 6 into 25. 6 into 25. So 25 by 6 to the power 4. This is constant. 6 to the power 4 is constant. Then I will go to Px equal to 3. This is 4, 3 and 5 by 6 to the power 1 and 1 by 6 to the power cube. So 4, 3 is equal to 4. 4, 3 is equal to 4. 4C3 is equal to 4. So 4 into 5. 4 into 5 is equal to 20. 4 into 5 is equal to 20 by 6 to the power 4. By 6 to the power 4. Now next I will come to Px equal to 4, C44. Then this is equal to 0, only 1 by 6 to the power 4. So then C44 is equal to 1. So 1 by 6 to the power 4. I got all the probability easily. So find out this. So you can calculate it. Okay student, I have calculated. You can calculate, see that it is come 625 by 1296. 6 to the power 4 is 1296. 1296. So 500, that you can calculate. I have calculated. Then I am going to find next is xpx. Why xpx? You know that corresponding random variable with the probability, their sum is nothing but mean. If you add all, xpx is equal to mean of the probability, mean of this probability. Now here x value multiplied here 0 and 1 multiplied, this is x into px 500, I did 500 by this. So 864, it's wrong, it is equal to 500, 308, 860, 864. Now its square multiplied with this 0, 1 multiplied with this, so 1 square is same 500 by 1296. 4 into 150 is 600. This is 600. And 1 square is 500 that. 2 square 4 is 150. 4 into 150 is equal to 600. And 3 square 9 into 20 is equal to 180. This is 180. Correction I did. So 416, this is 16. 16 into 1, that is equal to 16 by this. A little correction I did. So then if you add them, so it is 1100 plus 1, 1280, 1296. It is 1296, all I add 0 and this value 11 and this is, it is coming 1200 again, 500, 1100, 1280, 96, 1296 by 1296. 1296 by 1296 minus this summations and minus its square. So that is equal to 864 minus 1296 square. All of you know the formula of it. Addition of all this column, addition of this is called, we are writing x square into px is equal to 1. That is equal to 1, already 1. So here you can see these two are cancelled, 1 minus this square. If you calculate here, it will cancel, it will give as 2 by 3. It will cancel here, you will give 2 by 3. Its square, it is 1, and it is minus 2 by 3 square is 4 by 9. That is equal to 9 minus 4, 5 by 6. We got 5 by 9. This is your variance you got. All of you clear? I did by tabular form what you did by the NCERT book this. Now if you apply binomial, how easily you can do. This addition got 1296 by 1296. Its formula, all of you, this is 1 px square, your variance square. Variance I am writing is, those that don't know, it is equal to pi into xi square into pi minus mu square. This is your variance formula. So summation of xi square into pi minus mean square, that's I am applying here, and all of you did this way. If you mean I calculated here, if you cancel it, it is coming 2 by 3, and this is same, its square means 2 by 3 square, 2 by 3 square here you put, it is 2 by 3, it is equal to 2 by 3, 2 by 3 square, 2 by 3 square, so then 4 by 9 and calculated that. So if you want to find standard deviation, you can take its root over. If you want to find standard deviations, anybody want to find standard deviation SD, also he can do root over of root 5 by 9, which is always pi by 3, it is always positive. This is called standard deviations. This is called standard deviations. Why I have written all the things before you? Because how quickly we can find by the binomial methods. Now look at it, same thing I am doing here without calculating much. Only this step I write, these two steps, then over. So I can calculate everything. This is called probability distribution, binomial distribution table, and this is the calculation way. Now see that mean already by binomial, very interesting, n into p, n is number of trial, p is the probability of success. So n is equal to 4, all of you know that n is equal to 4, you have written n equal to 4 here, 4, put n value, and p is equal to probability of success is 1 by 6. Look at how easily you are getting 2 by 3. After so many, 2 cancel, it is 2 by 3, you got 2 by 3. Check here, you got also 2 by 3. After so much calculation, you are getting 2 by 3, but here by binomial formula, mean is equal to mean equal to NP, I got 4 by 6, 2 by 3. Then again standard, variance. So variance is equal to NPQ. Now multiply here, NP already you found, NP is equal to, this value already you calculated here, 2 by 3 into Q is equal to 5 by 6. 5 by 6, look at it, 3, it is equal to 5 by 9. Yes, it is found correct. After so many calculation, you got as 5 by 9 here. I am doing by the formula NPQ, it is 5 by 9. So if you go for standard deviation is NPQ root over, that is variance root over, that is nothing worried about it, that is the same way both the things you find. How easily you are finding here in binomial. So binomial, to find mean, you are n into p, n is the number of trial, p is the probability of success in one trial, and variance is NPQ, n is the number of trial, p is the probability of success, and q is the probability of failure in one trial. That way you are getting it. So now you can see how binomial is going to use to when the trials are independent. The coin question what I yesterday discussed, so getting a head is equal to half, getting a tail is equal to half, the 3 coins are tossed, so the number of trial is 3, random variable you know that it is 0, 1, 2, 3. So then you can find what is the mean. So n is 3 and half is the probability of success, 3 by 2, that you have yesterday find 3 by 2. Then NPQ you will get as is equal to, n is equal to 3, p is equal to 1 by 2, q is equal to 1 by 2. So the variance is equal to 3 by 4, and standard deviation it is root over root 3 by 2. Yesterday class those have attended, then I am discussing same thing. Many problem in the exercises there, you have to decide where it is with replacement. With replacement, then you will apply binomial. Without replacement, you can apply the combination or conditional. So again I am recapitulate how while you are writing probability distribution table for the random variable, you have to read the questions again and again, whether with replacement or without replacement. Most of the time with replacement it should be written in the question. Without replacement may write or may not write. If written, okay, you understood without replacement, you are going to find after each trial sample space is reducing, then we are going to apply that in Odia word I have used there, kami jibo, after each trial sample space kami jibo, first come represent conditional, second come represent the combinations. You can apply that combination and conditional to apply this about that distributions. And when if with replacement written, then you will going to apply this binomial to get quickly the probability distribution table, mean and variance and standard deviations. Binomial is only used with replacement. Now again I am recapitulate, any questions comes, then you have to read the whether is with replacement or without replacement. Nothing written, student again pay attention to me, nothing written you will consider as without replacement. Nothing written, no word written, neither with replacement or not without replacement, then you will understood that it is always without replacement, then you are going to apply combinations. Only it is written with replacement, then apply binomial distribution. I think everybody clear, and you can do probability distribution table by using combination or by using binomial formula. This is the formula you have to use for binomial. That's again I am writing general formula, Px equal to R is equal to NCR Q to the power N minus R P to the power R. P is the probability of success, Q is the probability of failure, R is the random variable values, N is the number of trials. And N is the number of trials, independent trials. Number of independent trials. So then this is easy to understand and easy to calculate. Thank you.